Alright, in this video we're going to talk a little bit about using truth tables in order to check for certain special logical properties that sentences might have. A sentence of sentinel logic, it might be what we call truth functionally true, meaning that it's true on every line of the truth table, or it might be what we call truth functionally false, meaning it's false in every line of the truth table. A truth functionally true sentence, that would represent a sentence of English which is what we call logically true, meaning that it's true no matter how the world is or how it actually is or might have turned out. That sentence would have to be true. Logically false is the opposite. That sentence cannot be true. Nothing can make it true. And a sentence of sentinel logic that doesn't have either one of those properties of being true on every line of the truth table or false on every line of the truth table is what we call truth functionally indeterminate. Now, if we're checking for these properties, what we want to do as little work as possible, right? So as long as we're getting all T's under the main connective or all F's, we need to keep working to see if it's truth functionally true or truth functionally false. But as soon as we have one of each, as soon as we have both a T and an F under the main connective, we know it's indeterminate and we can stop. So let's go ahead and check these sentences that I have written here. These all only need four columns. They only have two atomic sentences in them, P and Q. Remember, we're going to start on the right here and go TF, TF. And then we move one over to the left and go TT, FF. All right? And now we write this sentence up here. See if you can take a guess looking at this sentence and thinking about what these connectives mean, whether or not this will be logically true or logically false or indeterminate. So our main connective is this horseshoe here. Again, it's the one that's under the least number of parentheses. But we want to start with the one that's the most deeply buried under parentheses, the one with the smallest scope. And that's this conditional here. Well, remember, a conditional is true everywhere but where the antecedent's true and the conditional consequent is false, which is only on this second line here. Okay? Now, this is kind of what I mean by doing as little work as possible. A conjunction, in order to be true, both conjuncts have to be true, right? So we can look here and we know right away that it's not going to be, this conjunction is not going to be true on this line because it's false here. And because P is the left conjunct of this conjunction, it's not going to be true on these two lines either because P is false on these two lines. Well, what about here? P is true. This conditional is true, so it's true on this line and this line only. And that's one that we need to look at for this whole thing, for the antecedent to the conditional. So we can just go ahead and scratch these out if you want, right? So it doesn't distract us. Now we need to evaluate the main connective. Again, remember that that's true everywhere where the antecedent is true. So T, T, T. Well, we can't stop yet. This looks like it's probably going to be truth functionally true, right? We need to check this last line. Antecedent's true, and the consequent, which is Q, is also true. So this formula is truth functionally true. All right, pretty simple. So let's go ahead and reuse our truth table here and check this second one and see again if you can guess by taking a look at that whether it's truth functionally true or truth functionally false or truth functionally indeterminate. So our main operator here, it's the ampersand. We have two connectives that are outside of any parentheses, but again we go with the one that's a binary connective. All right. So the one with the smallest scope is this disjunction, so let's start there. Remember, disjunction is true everywhere except for where both disjuncts are false, so everywhere but on the last line of the table. And now this negation sign, the tilde that scopes over this disjunction, is basically just going to flip all of these. So now we need to evaluate the main operator, the ampersand. All right, and again, we know if one conjunct's true, we know that the conjunction cannot be true, so it's going to be false on these first three lines. What about this fourth one? P is false here, so it's false there as well. Even though it's true on this side, it's false. This conjunct is false. So that was a truth functional falsehood. It's truth functionally false. A truth functionally false sentence. All right, now let's take a look at this last one. Oh, I don't know why I erased that. So I have to make my truth table again. It doesn't take very long when you know what you're doing, when you've been doing this for a while. Okay, so my main connective is this conditional here. I guess I'll start with the disjunction. Remember, it's true everywhere that one of the disjuncts is true, so it's true everywhere except for where both disjuncts are false. And now the conditional, it's true everywhere except for where we have a true antecedent and a false consequent. So it's true here, it's true here, it's false here because the antecedent's true, and P, the consequent, is false. So we can go ahead and stop. We know what's up with this. We know that it's truth functionally indeterminate, right? It's true sometimes and it's false sometimes, like most sentences are.